Hello everyone, Dr. Chen here. In this video, I'm going to prove the hunter and the monkey problem. The hunter and the monkey. The problem says if there's a hunter see a monkey hanging on the tree, the hunter fire the rifle and the monkey scared release from the tree at the same instant the bullet was fired. And the problem states that if the hunter directly aims the rifle at the monkey, we can prove the bullet will always get the monkey, no matter what kind of velocity the bullet is. We can prove it rigorously. So let me first do some preparation work. So let's build our coordinate system. Let's see the place the bullet was fired. Let's choose it to be 0, 0, the origin of the XY coordinate system. This is our X, this is our Y. So let's see at t equals 0. What's the position of the bullet? The position of the bullet is 0 in X and 0 in Y. Because the bullet is here, so the x coordinate of the bullet is 0, y coordinate of the bullet is 0. Okay, now what's the position of the monkey? What's the position of the monkey? Let's call the horizontal distance from the monkey, just from 0, and we draw a perpendicular line towards the monkey is going to be moving along this. The monkey is going to move along this vertical line, right? So we draw a vertical line, we say this distance is d. So what's the position of the monkey? So x coordinate of the monkey at t equals 0 is d meter. And then y coordinate, let's just call it h. Y coordinate of the monkey at t equals 0 is h meter. Now we directly aim the rifle to the monkey. So we will have an initial angle of the bullet. We call it alpha 0. But we can see from trigonometry we should have tangent alpha 0 equals h over d. And we are going to use this equation later for our proof. Okay, so how do we prove it? We know the monkey released from the tree, the monkey will only move along this vertical line, right? And this vertical line, the x coordinate of the monkey is always d. And the bullet is going to fly in the air, so its x coordinate and the y coordinate always going to be changing. So we are especially interested when the bullet get to this, the x coordinate of the bullet get to d. So if we were extremely, so as the bullet fly in the air, if the x position of the bullet is exactly d, which means the bullet can be anywhere along this vertical line, what is the vertical position of the bullet? So if at a later time xb is d, the y position of bullet equals the y position of the monkey, the bullet gets the monkey. Now if y position of bullet does not equal the monkey, when the x position of bullet equals the monkey, the y position of bullet and monkey does not equal, so the bullet will miss the monkey, right? So that's the That's how we formulated this program mathematically. And now we can prove if we directly aim the rifle to the monkey, the bullet always get the monkey. So let's assume, let's give it a time. So let's say it takes a time. Let's just say that give it this time a special name. It takes t. Let's call it a t. It takes t for the bullet have that's the it takes time t for the bullet to travel to the same x coordinate as the monkey. Basically, when the bullet get to anywhere along this line. Okay, that's the same x as monkey. So, of course, the s coordinate of the bullet is going to be d. So, and we know in the x direction what kind of motion the bullet is doing. The bullet is doing constant velocity motion, right? So, distance traveled by the bullet equals velocity of the bullet, which is a constant, so it always equals to v0x of the bullet times t. And what is v0x for the bullet? So x component of the bullet, x component of the bullet is trigonometry, v0 cosine alpha 0, v0 cosine alpha 0. So we can solve for t. It's going to be d divided by v0, the initial velocity of the bullet in x direction. So it's d over v0 cosine alpha 0. Okay, that's how long it takes for the bullet to get you the same x position as the monkey. Now we don't know the y coordinate of the bullet at the time capital T yet, but we can calculate that. So right now we can calculate the y position of the bullet at any given time. At any given t, it should be the initial location of the bullet when t equals 0, and we know we have already defined the y position of the bullet at t equals 0 to be 0. So this term is just 0. Plus initial velocity of the bullet in y direction. Initial velocity of the bullet in y direction times this t and subtract 1/2 gt squared. This is a y position of the bullet. And already discussed, the first term is 0. Okay, what is the initial velocity of the bullet in the y direction? We can also know from trigonometry, right? It's v0 sine alpha 0. So it's v0 sine alpha 0, which is initial velocity of the bullet in y direction, times the t already solved. Subtract 1/2 gt squared. So we have v0 here, cancels. D sine alpha 0 divided by cosine alpha 0. Subtract 1/2 gt squared. Okay. which is simply d tan alpha 0. What is d tangent alpha 0? If we multiply a d on both sides of the equation I circled, we find d tangent alpha 0 is just h, under the condition that the rifle is directly pointing to the monkey when the hunter fires, right? D tangent alpha 0 equals h. So it's h subtract. So it takes time, capital T, for the bullet to travel from here to anywhere unknown. And we already found the y coordinate of the bullet. So we know what's the y coordinate of the bullet. Right now we need to find out what's the y position of the monkey. The monkey at t equals 0. The monkey is at h. The monkey is here, h. So the monkey. So what's the y position of the monkey as a function of t at any t? Y position of the monkey as a function of t. It should be the y position of the monkey at t equals 0, which is h, right? The monkey starts from y position h at t equals 0. And then at t equals 0, the monkey is going to do a free fall with the initial velocity 0. v0y monkey t, which is 0. And plus 1/2 ay monkey t squared. And we know this is h. This is half g t squared. So at the time capital T, at the time t equals capital T, the bullet is at a coordinate. So the bullet, its position is x bullet at t, at time t, and this t equals d divided by v0 cosine alpha 0. The x coordinate of the bullet is d. The y position of the bullet, let's check what's our calculation, is h subtract 1/2 gt squared. And for the monkey, at time t, at time, the x coordinate of the monkey is d. The x coordinate of the monkey is always d, right? Okay, what's the y position of the monkey? We calculate at time t. The h subtract 1/2 gt squared. So at time t, at time capital T, the x position of the bullet equals the x position of the monkey. The y position of the bullet equals the y position of the monkey. So of course, at the same location, so the bullet always gets the monkey. So now we understand, in this kind of situation, the hunter should always directly point his rifle to the monkey. Thank you very much for your attention. I hope you enjoy this proof.